everyone. This is the fireside chat on performance evaluation frameworks for autonomy. This is the second event in our series. The first one we did almost about a month back was on machine learning data strategy for autonomous vehicles. So this is our second event in the series where we'll keep talking about the importance and the value of data and how we harness the power of data to solve, autonomy problems around autonomous systems. So today we have with us a couple of my very esteemed colleagues from my previous experiences, Nick Horsborn and Melinda Korbor Kale. So they are joining us from different locations. So Nick and I, we worked at Aurora before in my previous life, and then Melinda and I recently worked at Motional, where they both are coming from. So how about we get some introductions out of our way and then, jump into the topic. So if I first may ask Melinda to go and then followed by that, Nick, and then
Absolutely.
we can come back.
Yeah, thanks so much, Sahil. Really excited to be here and talk about this very important topic. So hi, everyone. Like Sahil said, I'm Melinda Kothbar-Kale. I'm currently a senior autonomy engineer at Motional. Motional, if anybody doesn't know, is a robotaxi startup based in Boston, and we have operational sites in both Las Vegas and Pittsburgh. Currently, I'm working with our perception team to improve our onboard detection models that run on our vehicles. But I've also spent quite a bit of time at Motional doing end-to-end autonomy system performance evaluation, working to determine both the right metrics to use, and then also leading a team of engineers to actually implement the software and data frameworks that were needed to produce those metrics at scale. And prior to Motional, I was at another AV startup called May Mobility, where I worked as a robotics engineer across many different disciplines, perception, behavior, and again, actually performance analysis. So it's a little bit about me. Excited to be here.
Thanks, Melinda. Nick?
All right. Hey, everybody. My name is Nick Horsborn, representing Aurora Innovation. For those that may not be familiar, we're actually just a couple months out from launching our first product, which is long-haul trucking in Texas between Dallas and Houston. I'm based in Pittsburgh. Aurora has offices across the United States. So actually, my career started in the energy sector, where I spent 8 years as an operations geologist. And I'm assuming most people on here are like, wait, what? But for the past 9 years, I've been immersed in the world of autonomous vehicles, working across labeling for perception and motion planning, vehicle operations and mapping. For the past 4.5 years or so, I've been focused on autonomy triage and performance evaluation, helping to refine how we interpret, navigate, and respond to the world. So excited to be here today, share some insights from the journey and discuss some of what we've learned over the past few years.
Awesome. Good stuff. I was definitely one of the individuals who didn't know that Nick was in the energy sector before. So that was a news to me as well. And, when we connected on this particular agenda. So good stuff. So a couple of logistical things. If you have any Q&A, please drop them in the Q&A section of the Zoom, and then we'll take them towards the end of this discussion. So the format of this conversation is going to be a fireside chat. Essentially, myself, Melinda, and Nick, we're going to have a chat as if you're all just watching us talk virtually, and we'll just take questions towards the end. Now, unless there is a question which we find super interesting and in the flow of the conversation, then I know I can pick and choose in between. But keep dropping your questions, and as you hear us talk more about the agenda, we'll tee those questions up towards the end. Awesome. So the topic we have, right, is performance evaluation, and Nick and Melinda and myself, we have a lot of shared as well as individual experience in using the data for evaluating and benchmarking our autonomous systems end to end, specifically autonomous vehicles, including robotaxis and trucks and so on. So maybe one of the first, just kind of easing us into the conversation, right? We talk about autonomy product development, right? All the way from your understanding the business use case to building a solid technology and a product to meet that use case. So starting with perhaps Nick, from you, where do we see the role of performance evaluation and data in autonomy product development? Like, where does it fit into the sort of traditional product lifecycle? If you want to start first.
Yeah, of course, of course. So, yeah, I think at a high level, I think feedback data plays an absolute crucial role in the product development. I think the key thing I've been thinking about in prep for this conversation is just the continuous improvement, being a really important part of that, and system reliability, helping to get the system to be reliable and of course safe. So. I think just very generally speaking, helping to identify performance gaps, refine the system, ensure that the product ultimately meets the real world demands. Um, yeah, I mean, I think I'm happy to talk a little bit about some of the traps that you can fall into as well. But yeah, that's from a high level.
Okay. So performance evaluation and there are a bunch of these other what we traditionally call flywheels, right? Because they're like your continuous improvement iteration loops. You get the output, you get the data, you process that data, you use that to kind of feedback into your system, and then overall improve the sort of performance of your end-to-end product over a period of time. So Melinda, what's your experience on that? Like, what have you seen some of the data flywheels work better than the others? Where do you see this again, performance evaluation analysis fitting into the product lifecycle?
Yeah, yeah, definitely seen different versions of it, and I think a common theme of kind of where a lot of the work and effort goes to make it effective has really been on kind of obviously using the vast amounts of data that we're all collecting and labeling and triaging, actually using that, to get the most useful signal. And I think a lot of effort has gone into really refining what we need from that signal, because it needs to map really tightly between, obviously what a user would actually experience if they were riding in an AV or trucking, what the actual experience would be. It needs to map really tightly to like a numerical metric, right? That when it goes up, that means something is good, and when it goes down, that means something is regressed. But it has to be robust to kind of environmental factors. If we're thinking about on-road data, it has to be robust to simulation artifacts and things. And so that's where I think a lot of the work has gone. It's also where a lot of the trap kind of that Nick was talking about. There's tons of data, and I think that it's really about how you actually make use of that data. And I think that the problem I've seen too much is just too much data or an ineffective use of it to really map to what are the highest, the impact issues that we can address.
Right, and I think that opens up another, sort of an orthogonal point that we all say that more data is better, which is true in most of the times, right? Like more data you get, assuming that the utility of the data and what you do with it is proportionately getting better with the volume of the data. But speaking about some inefficiencies, right? Like when you have larger data sets for evaluating performance, along with not having very objective metrics, what are some of the other inefficiencies, Melinda, that you've seen where we have the data, we have the process, but we're just not able to make sense of that data? Like, can you talk to us a little bit about those inefficiencies, maybe one example or two examples?
Yeah, I think it's really easy. There's it's easier to be inefficient with your data than to be efficient. And I think some examples of things that I think I've seen across the board are really not having that really tight connection with the in-vehicle experience. So I think time and time again, I've seen, certainly in my career, the easiest way to get a real true signal of maybe what the biggest issue is with your autonomy system is for, me or one of my colleagues to just go sit in the car. And of course, that is just not scalable, right? We can't do that outside of a, research lab kind of environment. And so we have to find ways to really extrapolate that experience that we really care about and distill that into data. And so finding the ways, like the highest correlating factors of whatever data, like the massive amounts of data that we do collect, actually pinpointing, which signals from all of that data map the closest to what I'm actually experiencing in the car, so that we don't have to rely on, engineers' butts in seats kind of experiments.
Yeah, very true. I mean, if you can get everyone, just be in the car and get, feedback from the road and the field, I mean, that would be the most ideal, because you're almost, getting first-hand experience of whether you're in a truck or in a car or whichever autonomous system, right, you're talking about. A couple of things I think, for the broader stratification of the problem here, right? The data that we talk about is the overall data that you get from your platform, right? That could be your sensor data, that could be your telemetry data, that could be anything that is logged and captured on board for input into the performance evaluation pipeline. Now, the output of that could be a metric. Output of that could be a very detailed root cause analysis sort of classification of your problem. And then that further goes into creation of your simulations, creation of your other test cases, structured, unstructured, for system, subsystem, component level analysis. So I think that is the maybe that's the background we want to make sure people understand of our conversation.